All right, I'll get started. Can everyone see the screen?
Yep, you're good, Andy.
All right. So this summer I was put on the drainage improvement in Valley City. We installed a box culvert, some water main, um, reconstructed the frontage road, and there was a subcut on Main Street. Um, I'm going to talk about a little bit what to look for when inspecting and installation of the box culvert and water main. So, um, first thing is the phasing. So site prep, um, water main installation, outlet structure installation, and then box culvert, and then backfilling and finishing. So with site prep, first you got to get your temporary erosion control in, uh, do the clearing and grubbing that's needed. The contractor decided they thought they could do it all in 1 year, so we removed the pavement on all of the frontage road in order to install the water main. We had quite a few utilities running through the project that needed to be moved. MDU gas main was probably the biggest one, and they weren't able to really get that out of the way, so we ran into that a lot during construction. Um, that communication line was another big one that we had to cross under when we installed the box. Water main. So they started installing the water main first, and I guess the biggest thing is to look over the plans when you're first before they start installing it. A lot of the details will be found in the section 20 sheets of your plans. And then like for locations for hydrants and gate valves, fittings will be found in section 60. Um, when we were installing the water main, we had to connect into the existing water main in two spots. The first spot, we found that the existing water main was actually an asbestos pipe. So that was not called out in the plans. Um, we ended up having to call a consulting firm to come out and inspect the pipe to determine if it's the condition of it and the correct actions needed to handle and dispose of the material. It was determined that it was in good condition, and the contractor was able to um, remove the pipe and haul it to Jamestown for disposal. They had to wrap it and use correct PPE in order to cut into the pipe. So you can see here in the picture, they have their saw hooked to the water hose, and they also had a container with water to spray while they were cutting. The plans called for the box or the water main to actually go underneath the box, which would put it roughly 18 feet down. Due to the phasing the plans had, that's the route they was showing. And with the contractor being able to put the box in 1 year, they figured that it would be easier to go over top of the box instead of underneath. They came to the DOT and asked if they could reroute it, and we talked to the city and the designers, and they both agreed it'd probably be better to go over top than to bury it 17 feet underneath in case problems occur, in the future. So this slide here, you can see the water main going over top of the box. It actually ties in kind of back by that white pickup there to the existing main. So this is just about the end of the water main installation. They used insulation board to go underneath it and then over top of it because it was, I believe, 6 feet below grade when it went over the box, and then alongside of the box too. Now we got to the outlet structure. First they had to divert the stream. They used, I believe it was 1 6-inch and 2 8-inch pumps to divert the water around the construction area for the outlet structure. And those pumps ran 24 hours a day until that outlet structure was in place. For the foundation prep, the plans called for sheet piling around the outside and the front of the outlet structure. After the sheet piling was installed, they placed geogrid and Type R fabric and then reinforcing aggregate. And then on top of that, they used the poly insulation board on top and then place the concrete on top of that. In the picture here, you can see the poly board. So that's where the sanitary sewer ran through, and it was real close to the bottom of the outlet structure. I think we had like 6 inches to spare. So we put 6 inches of insulation board over it and hoping for the best on that. Once the foundation prep was done, they installed rebar, formed, and then poured. Biggest thing when dealing with forms is getting clearance on your rebar, making sure that you have enough space so the concrete can cover it. And then once they were poured, obviously testing of concrete and stuff like that. So we did run into a few problems. This was during construction. We had a couple big rain events and this hole flooded, I want to say at least 3 or 4 times like this. And they had to pump it out and clean it up and kind of start over. Here's another picture of when it flooded. Which actually kind of helped because the city came and said that their pumping station was running a lot of gallons of water constantly. And you can see here that when they were forming, they drove a stake right through the sanitary sewer. So they had to hire a guy, come out, scope the pipe, find out where the hole was. It ended up being right there, right where form stake was. So they were able to patch it, and city was there and signed off on it. So now we'll get into the box culvert installation. So pre-installation, you want to review your plans and specs, shop drawings, verify the survey data is correct, contact utilities, and then make sure your dewatering measures are in place. So upon delivery of the box, you should inspect every box that comes on. So we had a total of 316 sections of boxes, which equaled 1,703 feet. Out of those boxes, 140 of them were 5-footers, 146 were 6-footers, and 28 were mitered sections. So in the plans, and I'll show you else in future slides, it lays out how the boxes were supposed to be placed. Out of all those boxes, I think we only had to reject maybe 3 of them, and they got sent back to the site or the plant, and they were repaired and then sent back. Trench safety is a big thing when it comes to putting in box culverts and any underground work. We had OSHA arrive on site while installing, and they ended up looking the site over and shutting the contractor down until they were able to ensure their trench was safe. The problem was with the MDU utility line. It ran alongside the trench, and they weren't able to move it between the water main trench and the box trench in order to get a safe slope. So the contractor brought in trench box, and that's how we laid the boxes in for the rest of the project. Excavation, so we had Common X waste, and then rock excavation on this project. There was a dumping site in the project limits from way back when, probably 1930s. And you can see there in the picture all the trash. So that what they did was they hauled it in and they burned it. So it was all the leftover stuff that wouldn't burn. So bottles, cars, all kinds of stuff we found when we were digging through there. The plans called out 233 cubic yards of Common X waste to be removed. And we ended up removing just under 3,000 cubic yards. So there was a lot of garbage that we dug up. For Common X, is paid by the cubic yard, and due to the amount and how they were placing the box, we ended up paying planned quantity with and getting an agreement with the contractor in order to move things along smoothly. And with the Common X waste, it was hard to kind of keep track of it, so we just ended up doing load counts, getting a dimension of the box of the dump trucks that were hauling it, and then doing load counts and paying off it that way. Rock X, we found lots of rocks, and we ended up hauling out or removing 973 cubic yards of rock. And the one picture on the slide where the excavator's holding that rock is roughly the size of a pickup, which ended up, we just dug a hole alongside the trench and pushing that rock in because they weren't moving that out at all. Groundwater and runoff. So through this installation, we had multiple rain events which flooded our trench, and during the planning phases, they found high levels of metals in the groundwater. So we had a disposal of contaminated water, and the plans had 15,000 gallons. We ended up collecting just under 30,000 gallons. And due to the amount of water that was coming in from the stream, the contractor decided that we should try to collect that water and pump it back to the stream. So they put in 2 sumps along the box and pumped it back to the stream. We contacted the Department of Health and got the approval due to the contaminated water. And they said it'd be all right because that's the water that was moving up. And then any water in front of that was collected into tankers and hauled off site. Here's a quick video of them placing the base material. They used an excavator level to follow the grade, and then they'd rake it out, get ready to place the next section of box. So the plans called out to use foundation fill and or reinforcement aggregate for the base. We ended up using reinforcement aggregate the whole way due to the condition of the trench. It was wet basically every day in there from the groundwater. Placement of box. So you can see here, there's multiple mitered sections here where it curves around. The way the boxes came in, the contractor contacted the supplier and was able to organize it so that they would come in and then they would hit these curves and then have the mitered sections to place them. So here you can see the mitered sections going around where it comes along the frontage road. So they had typical sections, which was alternating the 5 and 6 foot box culvert sections, and then they also had sections where they had manholes to tie into the box. So you kind of had to keep an eye on what they were placing when they were placing to make sure they would land at the right station with those manholes and mitered sections. Here's the last mitered section they place. So this is the inlet. This is where they would tie into the stream again. You can see the old culvert there that we're replacing. That is running underneath the off-ramp in Valley City there. Here's another quick video time lapse of them installing the box. So the contractor would be able to roughly get 5 to 6 sections of box set in a setup with the crane that they had. So they would set box, excavate, move the crane, start setting, and then continue on. I think the best day we had setting box was like 90 some feet, which was pretty good. The joint material that was called out was mastic seal, Conwrap on the outside and mastic seal on the bottom. And then here you can see where plans show tie, where the Conwrap goes, the overlap. Backfilling. So here's the plans, how they showed they wanted it backfilled. We had GeoGrid and then type R fabric on the reinforcing aggregate. And then once the base was down and the box was placed, they used foundation fill to the top of the box and then Common X above the box. So make sure you're looking at your specs for, you know, lifts, testing frequencies. You know, the maximum is 200 feet for your trench. We had Braun Intertech for compaction testing on this job, which helped the contractor move along fairly quickly. We ended up having 13 proctors on this job, and they performed 739 compaction tests throughout the construction process, which if the DOT would have done it, it would have took some time, as you all know. But with the nuclear gauge, they were able to take the tests in minutes and have results to the contractor so they could put in a lift right after that. Post installation. So you want to walk through the box after it's been placed, check for any spalls. So when they're setting these boxes, you know, they're pushing on them and tightening the ties, and sometimes it'll spall out on the top or the bottom or the sides. So we'd walk through and check them, and then the contractor would go in and patch those areas. Verify everything was installed right. The gaps are good. Stream alignment works for the inlet. We had to adjust it a little bit, and in order for the stream to come into the inlet side correctly. Place erosion control. The plans didn't have any erosion control besides that blanket. So I decided that we should probably put some riprap in front, and then obviously we placed the blanket according to plan. So a little bit of field adjusting there, but you can see the light at the end of the tunnel. That was a good day. It's a long day of long year of setting boxes. So, and that's about it. That's the crew that installed it. They were his Landwehr Construction out of St. Cloud. They were really good to work with. It was hard at times to stay on alignment, I would say. Once you get off, it's hard to correct it. And once you get it corrected, it could start going the other way. So they were pretty good to work with. I was down there with the GPS checking grade and alignment just about every box section. And they also were down there with their GPS checking grade and alignment. So that's about all I have for today. Any questions?
Yeah, I got a question for you.
Yeah.
I've never seen the combination of GeoGrid and Type R underneath a box. Do you know just soil types, or you know why that was chosen?
I do not know. That was one of the plan notes that they called for on the outlet structure, and then continuing through the box. I mean, there is a lot of groundwater. I mean, there's slides all up and down Main Street here. So there's a lot of water coming through. I think that was probably the biggest thing. But
That's okay. Just out of curiosity too, in some of those rain events where you have so much sediment in there, how in the heck did they get all of that through that box?
so the box was big enough, actually, they could back their skid steer into the box and then push it out to the end, and then use the excavator to scoop out all the waste and haul it away. So
Wow. Okay. I bet that was a process.
yeah, it was really tight.
Nice. Oh, thanks, Andy. Good
But
presentation.
yep, thanks.
I have a question too.
Yeah.
With I guess having a curve in the box is a two-part. What was the most challenging aspect of the project, and then also with the curves, was there any issues with getting those joints to stay tight and within tolerance? I know even on a straight box at times, we can have issues with that. So, was there any issues with that?
No, actually, those miter sections fit like a glove, and the producer of the box, they did a really good job on it because I mean all of our joints came together great, and the plans called for 3/4 of an inch gap, and I bet you the biggest one was probably a 1/2 inch, and on all the box sections. So it went together a lot better than what I thought it was gonna, honestly. But the biggest challenge was, I would say, staying on alignment, because once you got off, you would just start veering, and there was times we got off a foot, and you'd have to kind of start working the box back in order to get it to get back on alignment. So
One question in the
Produce the
chat.
box.
Oh, go ahead. Sorry.
Oldcastle.
Okay.
Andy, one question in the chat was what was done with the contaminated groundwater?
So that was hauled to Valley City's waste ponds, and they would only take 15,000 gallons, and then the rest was hauled off to Fargo. And then eventually they were saying they were going to stop taking it, but we kind of started about halfway through the box, we really started getting less and less groundwater. So that was one of the contractor's biggest thing, because he's like, you guys are gonna break the bank if you guys keep paying us to haul this water out. So that's why we put in those sumps and got permission to pump it back, because a lot of that stream water, the elevation of the streams due to the weather was higher, than normal. So we kept on pushing it back up the trench. Any other questions?
There's one in the chat. Was there any difficulties in achieving proper density and moisture controls on this project due to the high amount of water that you seem to have been dealing with?
So at first there was, when we were doing the water main, and it about halfway through the summer, conditions changed to drier. So they were able to farm material out, and I honestly, that once we got halfway through summer, we had no issues at all with getting densities.
This is Adam with Grand Forks District. Did you guys
Yep.
were you guys able to use the E-gauge out there, or did you just do standard density testing with that?
Just standard.
Okay. I would have thought this would have been a great candidate for that E-gauge.
Yep. No, we just did standard comparisons, and then Ron used their nuclear gauge and for both water main and box and storm sewer.
Andy, what would you say was the average linear footage of excavation open at a time?
It all depends. So at first it was when we first started installing boxes, we were only doing like 33 feet a day. And I thought, oh my goodness, we're going to be here for 2 years for sure. And then once they got a new crane operator in and their project manager got on site, everything started going a lot smoother. And I mean, once we got around the first curve and headed down along Main Street, we were averaging probably, I would say, 70 feet a day. This was also my first box culvert that I've installed at the DOT, and I've been here for 14 years. So this is a good project. Got a lot of experience on this one.
How did the overall cost come in, Andy, and any notices or on the project?
I want to say we were under on a lot of things, but then we were over on some, like the Common X waste, we were way over. The water, due to the fact they did it all in 1 year, we didn't have any commercial grade asphalt, which was called for on the frontage road. So that saved a ton of money there. So honestly, I would say we probably ran under cost estimate, or if not, right on it. Any other questions? Well, thanks for your time. Casey's going next, so I'll stop sharing my screen and let him take over.
Okay, can everyone hear me?
Yep.
Okay. Let's see. My presentation is going to be on understanding contract documents. Get started here. Everyone see the slide?
Yes, sir.
Okay. All right. Understanding contract documents. On the agenda, we're gonna find out what is a contract document and how to resolve conflict in contract documents, and what are the different types of contract documents. Contract documents include all the written and legal documents that define the responsibilities, expectations, and scope of project. Each contract document is an essential part of the contract. A requirement occurring in one is as binding as though occurring in all. The department aims for the contract documents to work together seamlessly, ensuring they collectively define and encompass the entire scope of the work. Resolving conflict in contract documents. Resolving conflicts in contract documents is essential to ensure smooth project execution, maintain professional relationships, and avoid costly disputes. The process typically involves a combination of preventative measures, clear communication, and structured resolution steps. Conflicts arise from ambiguities, vague or unclear language in specifications or requirements, inconsistencies, contradictory information between the documents, i.e. drawings versus specifications. Errors or omissions, missing information or incorrect details. Change orders, disputes over scope changes or additional work. The types of contract documents in order of precedence. You have the addenda, special provisions, project plans, supplemental specifications, standard drawings, standard specifications. Utilizing all contract documents in this order should help minimize and resolve most conflicts that may occur during the project. Addenda. What is an addenda? An addenda is written or graphic document issued before a contract is signed to modify, clarify, or supplement the original bidding documents or contract documents. The addenda takes precedence over all other contract documents. The purpose: to address errors, omissions, or ambiguities in the original documents. To provide additional information, such as responses to bidder questions, and to make changes to the scope of work, project schedule, or specifications. The addenda is issued before the contract execution. The addenda is released during the bidding or proposal stage, ensuring all potential contractors or bidders have the same updated information. Once issued, an addendum becomes an official part of the contract documents and must be acknowledged by all parties in their proposal. Addendum is legally binding. Importance: transparency and fairness ensures all bidders work with the same updated information. Conflict avoidance reduces disputes by clarifying ambiguous or incomplete information. And compliance ensures the project meets all legal, regulatory, and client-specific requirements. Examples: revisions to drawings or plans, updates or corrections to architectural, engineering, or site drawings. Changes to specifications, adjustments to materials, performance criteria, or standards. Responses to questions, clarifications or ambiguous or unclear part of the original documents. Additional requirements, new instructions, regulations, or work details not included initially. All right, special provisions. What are special provisions? Special provisions are clauses or sections within a contract or project documents that outline specific requirements, conditions, or modifications unique to a particular project. They are used to address project-specific needs that are not covered by general specifications, standard provisions, or industry normals. Purpose: adaptability allows the contract to address unique project demands. Risk management reduces ambiguities by specifying requirements tailored to the project. Alignment with stakeholder needs ensures the project meets owner, regulatory, or community expectations. Project-specific conditions, requirements for unusual site conditions, special material requirements, or substitutions. Environmental or safety standards, measures for handling hazardous materials or minimizing environmental impact, compliance with local environmental regulations or safety standards. Administrative requirements, unique reporting or documentation protocols, specific project milestones or delivery dates. Local or regional regulations, provisions to comply with local building codes, permits, or ordinances. Labor and workforce requirements for using local labor or specific trade certifications. Project plans. Project plans are comprehensive documents or sets of documents that define how a project will be executed, monitored, and controlled. They serve as a roadmap for project teams and stakeholders, outlining the scope, objectives, schedule, resources, and procedures necessary to complete the work successfully. Components. You have the scope of work, project notes, estimate of quantities, basis of estimate, typical sections, detail sheets, plan and profile sheets, survey data, layout sheets, and standard drawings, environmental notes. The purpose. Guidance and coordination. Ensures all team members and stakeholders understand their roles and responsibilities. Baseline for performance. Acts as a reference point to measure progress and performance. Risk mitigation. Identifies challenges in advance and outlines solutions. Stakeholder communication. Promotes transparency and alignment between all parties involved. Scope of work. Details the project objectives, deliverables, and boundaries, and specifies what is included from the project. The schedule is a timeline showing key milestones, deadlines, and critical path activities. The budget specifies the financial resources allocated to the project, includes cost for labor, materials, equipment, and contingencies. Roles and responsibilities. Identifies project stakeholders, team members, and their respective duties. Includes organizational charts or responsibility matrices. Resource plan outlines the materials, equipment, and labor required for the project. Ensures availability and allocation align with the project timeline. Risk management plan identifies potential risks and their impact on the project. Includes mitigation strategies and contingency plans. Quality plan describes the quality standards the project must meet. Specifies inspection, testing, and quality assurance procedures. Communication plan defines how information will be shared among stakeholders, includes meeting schedules, reporting formats, and escalation procedures. Safety plan addresses measures to ensure worker and public safety, includes compliance with legal and regulatory safety standards. Environmental or compliance plans addresses requirements to meet environmental, legal, or regulatory standards. All right, supplemental specifications are modifications, additions, or updates to an organization's standard specifications for construction, engineering, or other types of work. These are typically issued to address changes in policies, procedures, standards, or advancements in technology, ensuring that the specific specifications remain current and relevant. These are not as common anymore as we typically get a new spec book every year. The purpose is to update outdated provisions in the standard specifications. Incorporate new materials, methods, or technologies. Address gaps, ambiguities, or areas needing clarification in standard specifications. Supplemental specifications work alongside standard specifications, but take precedence when there are conflicts. They may revise specific sections or introduce entirely new sections. Project specific or general use. General supplemental specifications are issued by an organization for use across all projects. Project specific supplemental specifications are tailored to address unique requirements of a particular project. Once incorporated into a contract document, they're legally binding and must be adhered to by all parties. Material updates, replacing discontinued material with an alternative that meets the same performance standards. Construction methods, introducing a new technique that may improve efficiency or safety, or requiring stricter tolerances or quality standards. Policy changes, aligning with new local, state, or federal regulations. Safety standards, aiding enhanced safety measures or protocols for specific types of work. Important, keep standards current, ensures specifications reflect industry advancements and regulatory changes. Enhances quality and safety, implements updated practices for better outcomes. Reduces disputes, clarifies requirements that may have been vague or ambiguous in standard specifications. Standard drawings are pre-approved detailed technical drawings that depict commonly used design elements, construction methods, or components in a consistent and standardized measure. These drawings provide a uniform reference for designers, engineers, contractors, and other stakeholders involved in a project. Purpose. Consistency ensures uniformity in design and construction across different projects. Efficiency reduces the time required to create custom drawings for standard elements. Compliance aligns with industry standards, codes, and regulations. Quality assurance minimizes errors by providing clear, standardized instructions. Common applications. Infrastructure projects. Roadway details, i.e. curbs, sidewalks, or drainage systems. Utility installations, i.e. electrical conduit, water pipelines. We have structural components. Those are reinforcement details for beams, columns, and slabs. Pre-engineered connections or joints. Safety features. Guardrail barriers, signage, and lighting layouts. Benefits of standard drawings. Simplifies communication. Provides a clear visual understanding of construction elements for all stakeholders. It improves efficiency. Saves time during design and construction phases by reducing the need for custom drawings. It's cost effective. Lowers design costs and standard elements don't require repeated engineering. Error reduction. Minimizes misinterpretations and inconsistencies in design and execution. Facilitates training. Easier for new personnel to understand and follow standard practices. What are standard specifications? Standard specifications are detailed, pre-written documents that define the requirements, guidelines, and standards for materials, construction methods, workmanship, and quality assurance for various types of work. They are typically developed by organizations, agencies, or industry bodies to ensure consistency and compliance across projects. Characteristics. Pre-established, developed for general use in multiple projects rather than being project specific. Approved by relevant authorities and organizations. Comprehensive. Cover a wide range of construction activities, materials, and performance criteria. Baseline documents. Provide a foundation upon which supplemental specifications or special provisions can be added for project-specific requirements. They are legally binding. When included in contract documents, they become enforceable standards for the project. Purpose. Consistency. Ensures uniform practices and quality across different projects. Efficiency. Reduces the need to draft specifications from scratch for each project. Quality assurance. Establishes minimum standards for material, workmanship, and testing. Compliance. Ensures adherence to industry codes, regulations, and safety standards. Components. General provisions. Define contractual terms, responsibilities, and administrative procedures. Examples. Payment terms, project schedule, or inspection requirements. Materials. Specifications for acceptable materials, including performance characteristics, grades, and testing methods. Examples, concrete mix designs, asphalt specs, or steel reinforcement. Construction methods. Detailed instructions for execution of work, including equipment and techniques. Examples, earthwork procedures, paving methods, or utility installation. Testing and inspection. Requirements for quality control, material testing, and inspection.
Casey, you might have muted yourself.
You hear me now?
Yep.
Okay. Standard specifications. Advantages are cost saving, reduces time and expenses associated with drafting new specifications, simplifies bidding. Contractors are familiar with standard specifications, making it easier to prepare bids. It minimizes disputes. Clearly defined requirements reduce ambiguities and potential conflicts. It improves quality, promotes adherence to established best practices and quality benchmarks. Any questions? All right, well, thank you. That's all I have.
Thanks, Casey and Andy. Next up, we have Minot District with Hunter starting us off.
No. All right, can everyone hear and see the presentation okay?
You're good, Hunter.
All right. Good morning. Today I'm going to talk about haul road inspections. So the relevant specification is 107.08 haul roads, which can be found on page 64 to 66 of the 2023 and 2024 editions, or 66 to 68 of the 2022 edition. Designation of a haul road. The entire cycle of the haul should be considered, including loading and unloading. Should be a non-paved road unless on the state system. It should not be susceptible to damage from heavy hauling, though the contractor may provide improvements to make the road suitable at their own costs. Would not be hauling from an established commercial pit, which would have long-term facilities in place and derives income from annual sales or non-government contracts. The operator owns and operates or has a long-term lease for the land, and the pit was not primarily set up to serve NDDOT projects. And the operator regularly advertises public sales of materials. So before hauling begins, a pre-haul inspection should occur, including the engineer, contractor, and responsible agency. After the pre-haul inspection, the engineer will make an inspection report, which will include the type of material on the road, the thickness of that material, the width, and any special conditions such as the weight limit of that road. In the picture, we see the equipment that we use to take the thickness of it. We pound that into the road. It has a notch along the side of it so that once you hit the clay layer, you can see it. So then you put that to where you measure to the top of the road in order to get your thickness. What? Are my slides advancing for you guys? My coworker just came up to me and asked.
Yes, on my end, I'm seeing on somebody else in the chat said the same. I see the yeah, I see the pre-all inspection slide.
Yeah, that's
Okay.
what I see.
So it looks like a couple people are having issues. Slides. Slide 1. All right. Well, hopefully that figures it out. All right, so after we begin hauling, we need to focus on maintenance and restoration. We must accommodate public traffic. We're not the only ones who use the road. Farmers are moving their equipment. People are traveling from place to place. Dust control is what you'll probably get your most common complaints on from the public. Just make sure that the contractor waters it in order to keep that dust down and prevent it from becoming an issue. Soft spots are another thing that can occur. Just have the blade dig those up and recompact them back so that they are no longer presenting an issue. And once hauling has been completed, there needs to be a final inspection. Again, the engineer, contractor, and responsible agency need to be a part of it. The contractor needs to restore the road to a condition at least equal to the condition before hauling. After they have done that, obtain a road release statement from the responsible agency, releasing the NDDOT and contractor from further responsibility. Any questions? All right, hearing none, thank you.
Thanks, Hunter. Eric, next.
Right, good morning, everybody. Today we're going to talk about change orders, what's all involved with them, what should be included in them, the approval process that we go through with change orders. I know it's every project engineer's one of their favorite topics. Let's see here. Okay. All right, let's start off with what is a change order. So change orders are written order from the department to the contractor and signed by both parties, detailing contract revisions for the work that is within the scope of the original contract. Change orders also address modifications to the contract, such as changes in plans, changes in specifications, any additional special provisions that need to be added, any plan quantity changes or changes in the construction of the project necessary to satisfactorily complete the work. Also, please note that every change order will include whether an adjustment to the contract time will be added or not, even if there will be no change to the contract time. Please follow spec 10806 of the standard specifications when determining if a time adjustment is warranted. Now, when is a change order warranted and when is it not warranted? On the left of the screen there, you'll see most of the time change orders are warranted if there's design changes. This may include plan errors and omissions. Any work that needs to be added to the project due to unknown conditions, typically subsurface conditions, any design changes to improve the project for the public interest, any changes that give us a better project for an equal or less cost. Also, there could be specification changes that could also include better products for equal or less cost. The contractor not being able to construct or supply what's specified in the plans, or if the original specifications are not suitable for the project. There's also contract administration issues such as NOIs, any price deductions not covered by special provisions, or any haul road related issues not covered in the PS1 prices. There also is other categories. These three: design changes, spec changes, and contract administration issues may not cover what you're seeing in the field. Now, when is a change order not warranted? So any non-compensable delays, those are within section 10806 of the standard specs if you want to look those up. Any quantity overrun or underruns that are not considered a major work item. The major work items are specified in the standard specs. I believe if the particular bid item isn't 5% of the total contract cost, it's not considered a major work item. Any changes in supplier costs post bidding, those are also not warranted for a change order. Any work included in PS1 price schedule included in the contract proposal, also not warranted for a change order. And any incentives or deducts included within the special provisions are also not warranted for a change order. A big thing to please note is that change orders need to be approved prior to any work commencing included in the change order. That's a big one. Now we'll go over what are the elements of a change order. So there are 4 elements. The first would be a detailed explanation of the change to the contract, which is what gets written up in CARS and sent to the contractor. There's also a project engineer cost justification that should be attached to the supporting documentation. Also, supporting documentation, this includes any contractor quotes, any pricing that you receive, and then finally signatures from the final approval authorities required for the change order. So the first element of a change order, the detailed explanation. What should we include in those? Here are some of the major things that need to be included. We need to include why the changes are needed and or what caused the change on the project. We also need to include how the change within the change order differs from the original plans. Another thing would be how the change benefits the project. A lot of the times, interest to public safety, we get a better product for equal cost, things like that, of that nature. Also, we need to include a breakdown of how the work will be paid for. What are the new bid items that are going to be added? Is it going to be paid by a lump sum, by square yardage, tonnage? What unit is going to be used? Also, does the change affect the project schedule and or completion date? So do we need to add days to the project or does it stay the same? Also, a helpful tip at the end of your change order write-ups, what we typically do in the Minot district, which is helpful. We include this disclaimer that this change order is full and complete compensation for all labor, materials, equipment, direct and indirect costs to perform this work. The reasoning for this is it helps prevent any future claims from the contractor on what is included within the change order. Another thing to note on your change order write-ups, please make sure they're easily understood by someone who is not familiar with the project. So this will help final approval authorities understand what's going on the job. And then also, if we ever get by FHWA personnel Typically, the people looking at these are accountants or auditors that they're not engineers. They don't understand what we do out on the projects. So the simpler and the more clear you can make your write-ups, the better. Moving on to the second element of change orders, the project engineer cost justifications. So what are these? They are a summary report completed by the project engineer detailing how the change order negotiated price was achieved and how it is within reason. Typically, our cost justifications should be like a report, should be longer than 3 or 4 sentences, should have exhibits in it. They should be most of the time longer than a page, showing your reasonings of how you guys agreed to your prices and how they were negotiated. Elements that need to be included, detailed price comparisons completed by the project engineer. Typically what we do here at the district and what it's our best practice is to compare what we receive from the contractor in their quote, and then we compare it to a potential force account scenario using section 10903E, which covers how we pay for labor, equipment used, any materials received, markups required for that for subcontractor work. And then you should also include conversations with the contractor outlining price negotiations and how the final dollar amount was received. Typically, there's going to be some back and forth between the project engineer and the contractor. Contractors typically are going to come in high with their quotes. Project engineers are typically going to come in lower, and the middle ground is going to be reached. Please include conversations on how you guys reach that middle ground, any emails, back and forth, and you know, just how you got to where you are. Also included in the justification should be a detailed breakdown of how the change order elements will be paid for and under which new bid items will be added to the project. That one's pretty self-explanatory. And then finally, at the end of your change order justification report, you should include a recommendation by the project engineer on why the price negotiation should be proved and why it makes sense, why it's beneficial to both parties. Just also to note, comparing past annual average bid prices is rarely a good choice for cost justifications. Reason I say that is when you go through a force account scenario, you get more detailed on equipment rental rates and labor rates. And for some of these smaller quantities, the annual average bid that we have posted on the DOT site won't encompass all of what's going on in that work. And most of the times is not a good comparison for what you're doing. Here I included example from one of our past projects and what was included, some cliff notes of what was included in the cost justification. So in the top left, this is what we received from the contractor. A little background on the project. We had a 2-inch mill and overlay project. The road was fairly narrow and we had some steep drop-offs on the shoulders. And rather than having the contractor haul the millings to a stockpile site, they requested if they could lay them down straight from the milling machine onto the shoulder, shape and pack them, and help build up our shoulders rather than hauling them to the stockpile site. So we received the quote up here in the top left from the contractor on what the potential cost savings would be to them for laying down the material versus hauling it to the stockpile site. I went through and looked at within their request to sublets, they had subcontracted trucking companies to haul the millings. I reviewed that and their subcontracts of what the hourly cost would be to haul the millings versus what it would be for a force account. And it showed a cost savings there for not having to haul the millings to the stockpile site. Also went through table 3 here and reviewed what they submitted for labor to lay down the millings, shape and pack them. And going through force account with the equipment blue book rates and the labor rates and all that, we showed an additional cost savings. And then when we went and reviewed their mobilization costs, we actually saw that they were a little high. But when we went through and balanced all of these costs, it showed a roughly $6,000 cost savings to the department for us to be able to lay millings out on the shoulders, correct the safety slopes, and ultimately give us a better product. How we ended up paying for that was we made a bid item for milling pavement surface by the square yard, and it only cost us roughly $3,500 to lay down millings over, I believe it was 5 or 6 miles of roadway. So ultimately, it gave us a better product for a reasonable cost. It cost us a lot less than having our maintenance forces doing it after the fact, and laying milling down for roughly a penny a square yard seemed like a pretty good deal for the district. Just touching base on supporting documentation, that should also be included in your change orders. Material invoices would be one. You should get those from the contractor or the material supplier. Shipping and freight costs, we will typically pay for those within a change order. Review the subcontract agreements in your request to sublet. That will typically give you trucking rates, any work done by the subcontractor. You can compare those from what you're being quoted. The equipment Blue Book rental rates, we get those from construction services. So if you need those, request those. They give them the equipment, make, models, and years, and they will give you what the rental rates for those should be. And then also when it comes to labor, those are pretty simple. You look at your contract proposals and they all contain the U.S. Department of Labor rates, or I should say most of the time they can contain those. And then you go through and you have your basic hourly rates and then your fringe benefits, and you apply your applicable markups and you get your labor rates. Moving on to the approval process for change orders. So there are several different types. This slide here goes over DOT projects. Approval requirements are based on cumulative change order costs and/or contract time extensions. So this table here on the right is taken directly from the construction records manual. It's a very good tool, lays things out very simply on the final approval authorities and who needs to review these before you send these to the contractor for signature. Please note to notify the approval authorities immediately when you know there's a potential for a change order. Don't wait until 2 weeks after you know you have a change order and you're done with the write-up and the contractor's bugging you that we need to hurry up and get this signed and the work done. So please notify either the district or the project engineer or whoever needs to know. Please let them know as soon as possible, whether that be an email or a phone call. Another thing to note is that if we do have a design change, we need to let the design engineers or the structural engineers know what's going on. Typically, that won't be the fastest process to get stamped plans changed. So please let people know as soon as possible. Another thing to note as far as approval authorities go, any categories B, C, and D all need approval from Office of Operations. So those are structural design changes, changes in specs, or changes that affect environmental commitments. Again, please notify somebody immediately when you know these are coming. It's a higher approval authority, and Office of Operations needs to know as soon as possible so they don't get blindsided with a change order that they know nothing about. Now, approval processes for local agency funds on a DOT project, there are some caveats in there. So any change orders for work that only have local public agency funds associated with it do not require approval from the department, regardless of the amount or reason for the change order. So if you have a project going through town and it only has city funds associated with a sidewalk, if a change to that sidewalk is needed, you only need the city to sign off on that. I would note, please let the district know what's going on. I know we don't have to approve it, but we still like to be kept informed on any changes to the projects. Also, if a change order contains a combination of federal, state funded work and local agency funded work, then the change order approval must follow the change order process shown on the previous slide for all DOT projects. So if a project has a mix of state, federal, and local agency funds, you will need everyone's signature on that. Approval processes for non-DOT projects. These also have some caveats. If there is no federal funding on non-DOT projects, then the DOT does not need to review these change orders. Again, we do like to be kept informed though, just to know what's going on. If a non-DOT project does have federal aid, then the change orders need to be approved by the DOT. If there's non-participating funding, then the approval must be given from the owner that has those non-participating funds. So that would be the cities, counties, townships, whoever's involved with those. The department will review change orders that exceed any of the following criteria to determine if the costs are eligible for federal aid. So that directly correlates to that table I showed earlier. Basically anything over the project engineer's authority, which would be $10,000 or a time extension of 5 working days. If the federal funds authorized in the cost participation agreement with the local agency are exceeded and no federal funds are available for any change order, the local agency will assume the total cost of the change order. One thing to note with that, on any of these local agency jobs, please check with the department to see if we have federal funds available. Otherwise, the local agencies will get stuck with the bill. If the federal aid participation on the project is limited and the limit is reached, the DOT will no longer review and approve subsequent change orders for federal aid eligibility. The owner will be responsible for those extra costs. Again, check with the DOT, see if we have any federal aid available before you go through with any change orders. Another thing to note, any emergency relief projects, there is a scope in there that you have to have FHWA concurrence prior to the change order. Anyone who's dealt with FHWA probably knows it's not the fastest process. So if you do get put on one of these projects, please be aware of that. In summary, what do we need to include with every change order in CARS? We need approval from the final approval authority prior to sending the change order to the contractor for signature. That is a big one. We do not want to see change orders come back with contractor signatures that the districts or whoever has no idea what happened and they're already signed. It's not a good thing. We need a well-written, detailed explanation. Again, people who are not familiar with the project or have no engineering knowledge need to be able to read these and understand what's going on very quickly. Need to be clear and concise. Project engineer cost justifications need to be included. Again, those break down how the negotiated price was received and how you got to where you are. Supporting documentation also needs to be included. This includes contractor quotes, Blue Book rental rates, labor rates, any freight costs, any subcontractor costs, basically how you got to where you are. And finally, all change orders need to be signed by the contractor and final approval authority before work begins. Should there be a case where work needs to begin for safety reasons or emergency reasons, the project engineer and inspection staff can track that using force account sheets and then later come back and do a change order. But I would say in most all circumstances, change orders need to be signed before the work begins. And lastly, if all else fails and you can't come to a negotiated price with the contractor, direct the work to be done using force account tracking methods and proceed from there. Any questions?
Eric, just I guess, the project, the justification, I guess, just I guess just a statement, right? That's something that the contractor doesn't need to see, but that's something that we supply to the change order, right?
Correct. That's something that should be attached in cars. Basically, a detailed report of how you and the contractor got to where you are. But yes, you're correct. That's something that only gets uploaded to cars. It doesn't need to be shared with the contractor.
See a couple questions in the chat, Eric. One is, who do we contact to determine if additional federal funds are available for local agency projects?
If it's local agency funding, I would contact the local agency. If you're wondering if we have any federal funds available, I would contact your FHWA responsible charge person, and then I believe we would contact either CAS or whoever the local government representative for that contract is in central office.
So Eric, do you review other change orders, or is it the ones you prepare? I guess if you review others, what do you typically see missing from those change orders that cause you to pause? And then
So-
second question. Well, I'll let you answer that one first, then I'll ask another one.
Okay, sounds good. I guess I like to see all the change orders that I'm the responsible charge on before they go to the contractor. Typically, what I see is the change order write-ups are lacking quite a bit, or the cost justifications are lacking any. I guess like what I do is typically review it for the force account. A lot of times I'll see change order justifications that they review the annual average price, and if they're somewhere within the ballpark, yeah, they work. Yeah, we agree with the price. Well, no, I like to see a little more in depth there. The annual average is throughout the whole state, and a lot of times for these specialized change orders, they don't really apply. So I like to see them all. I like to review the change order write-ups, make sure they're clear and concise, and have a little depth to them.
Do you typically see the project engineers submit them timely, or are a lot of them after the fact, or is that, I guess, do you have pretty good luck in your district with getting them submitted when they're supposed to?
Yeah, lately I have. Depends on who you're dealing with, but I think if you can, I guess the consultants that you deal with, if you can get that precedent set up front that, hey, I like to see the change orders and review them before you send them. Typically I've been getting them in a timely manner. The time delays are usually on the contractor side when you're asking for price breakdowns and when they're just giving you lump sums.
And one last one. In Grand Forks here has been drilled into our head, and I think it's part of 23 Code Federal Regulations that a cost analysis must be performed. Do you typically separate the cost analysis from the justification, or do you include that with your justification? Yeah, I used to have a separate sheet that just for cost analysis, just to show that I guess I always treated it as a kind of like the engineer's estimate, to show that you run through the calculations and you have that information in advance. So just wondering how you address that.
So I'll typically include that cost analysis in the cost justification. If my slides will go back here. So like you'll see table 1, 2, 3. So I'll include these through my write-ups and use these as exhibits and tables, and then have paragraphs before and after comparing the costs. And like you said, it's basically a cost analysis within the justification. So I kind of mix them together, if that makes sense.
Thank you.
All right, thanks, Eric and Hunter. That wraps up today's session. We'll come back next week on Thursday at 9 again. We have Grand Forks and Devil's Lake. Thanks, everyone.